We're trying to find the area of the region enclosed by these graphs. So I'm going to put a little xy plane. Y equals 0 would be the x-axis. Y equals 1 over x would be this hyperbola. And also x equals c and x equals 1. Now c is some number between 0 and 1. So let's say this is 1 right here. It's not to scale. X equals c is somewhere in between 0 and 1. We just don't know where. And we need to find the area of this region in terms of c. That means we need to integrate a bunch of these little tiny rectangles, add those areas up, and it's the y top minus the y bottom. The y top is 1 over x, the y bottom is 0, but you don't need to write minus 0. So that gives you length. The tiny little width cuts are dx to bring it from length, one-dimensional, to area, two-dimensional, and from x equals c to x equals 1. And now we integrate. The integral of 1 over x is the natural log of the absolute value of x. We don't need the absolute value because we're dealing with positive x's. Plug in the 1 minus plug in the c. Natural log of 1 is 0, but negative natural log c is not one of the answers. So you have to use the log rule where if something is multiplying to a logarithm, on the outside of it, it becomes an exponent on the inside of it. So this turns into the natural log of c to the negative 1, and c to the negative 1 is 1 over c, so the answer is B. This next one is very difficult to read. The region bounded by the x-axis, let me get my pen working again. So we are bounded by the x-axis, y equals cosine x, but between negative pi over 2 and positive pi over 2. And so we're looking at the region that is bounded between these two. Now this region is separated into two regions by the line x equals k. And the area for the region, and what this is saying is for all x in between negative pi over 2 and k, that region is 3 times the area of the region for the values of x that are greater or equal to k within the region. They really probably should have put less than or equal to pi over 2. That would have made a lot more sense right here. That would have been more clear. Anyway, we've got a vertical line k. And it is creating two areas. Let's see. The area that I am shading in yellow is 3 times larger than the area I'm going to put in powder blue color. So what that means is the integral from negative pi over 2 to k of, and this region is formed by little rectangles where the top is cosine x, the bottom is 0. This is equal to 3 times the area of the powdered blue, the area of the powdered blue is the integral from k to pi over 2 of, again, cosine x dx, has the same top and bottom of rectangles. Now we have to integrate by hand to find k. So the integral of cosine is positive sine. And again, integral of cosine is sine. Fundamental theorem of calculus says I have the sine of k minus the sine of negative pi over 2. And if you stop to think about it, the sine of negative pi over 2 is equal to negative 1. And that is equal to 3 times the sine of pi over 2, which is 0. So the minus the sine of k. Now, solving this equation, I have sine k, or sinc, plus 1 is equal to negative 3 sincs. Add 3 sine k's, or 3 sincs. Subtract the 1. And that was not the same one that I came up with earlier. So what did I mess up on? You probably already know watching this video. At 3 times, I plug pi over 2 in. The sine of, this, silly me. The sine of pi over 2 is 1 minus, and then the sine of k. That changes things. So now I have 3 minus 3 sine k. It's because I was getting too focused on the fact that I spelled out sink. Maybe. Add the 3 to the other side. I have 4 times sine k equals, subtract the 1 over, I get 2. This gives me sine k is equal to 1/2. And the angle has to be between 0 and pi over 2. So an angle that is equal to 1/2 between 0 and pi over 2, pi over 6. Next problem. Again, this is without a calculator. So we have a region R in the first quadrant that is bounded above by the line y equals 1 plus 4x. And I had to draw that a little less sloped than it should be, but just trying to get an idea of the picture. So that's its above boundary. It is bounded below by y equals 3 to the x, and we know that exponential functions go through the point 0, 1, and they will intersect somewhere. And I exaggerated both their drawings so I could see it within this region. So, now, we need to find the area of R and figure out which of these integrals is correct. If I decide to do vertical rectangles, then y top is 1 plus 4x minus y bottom is 3 to the x. And when I have vertically drawn rectangles, the tiny cuts to make it a rectangle are horizontal, dx. And x exists from 0 to this intersection point, which turns out to be 2. We can double check that by plugging 2 into x. Plugging it in here gives me 9. X equals 2, y equals 9. If I plug 2 into 3 to the x, I can see I also get 9. So that intersection point is 2, 9, and you can see I'm obviously off scale. And if you look at this, this is the first one. So number 1 is definitely true. Then I need to move on to what if I'm dealing with dy? So if I'm dealing with dy, I'm going to erase this and try to redraw what I had. So if I draw my rectangles horizontally, then the vertical dimension is the one that is the teensy tiny cut, and it's a dy integral for delta y being one of the dimensions. I have to put the y values down that this region exists between, and that would be 1 and 9. Then I also need the right x minus the left x. The right x is coming from y equals 3 to the x, but I have to isolate x. So the inverse function of 3 to the power of is the natural log of 3. So I can natural log of 3. Yeah. Start again. The inverse of 3 to the x is log base 3. However, when I look at the way they write this, they have a change of base formula going on, or I could look at it this way. If I take the natural log of both sides, a log rule says that the exponent, this x, can become a multiplier in front of the logarithm, no longer inside of it. When I divide by the natural log of 3, I get that x is equal to, when I divide by the natural log of 3, I get the natural log of y divided by the natural log of 3 is what x is equal to. So that is my right x. Minus my left x is isolating the x in this line. So y minus 1 equals 4x, divide by 4, and you have y minus 1 over 4, which fits number 3. And number 2 is definitely wrong because it's trying to use the x coordinates instead of the y. So 1 and 3 are the correct answers. And that's it for the no calculator problems.